5.5 on special cases of factoring. So we'll start with the difference of two squares. A squared minus b squared is equal to a plus b times a minus b. So here is an example. How do we know that the second term is a square? Well, we can think, is there a number? Can I take the square root? We can work backwards. Am I able to take the square root of 9? And if so, then that number is a square. 3 squared is the same as 9. So my factors of 2 squared, I have x squared minus 3 squared, so that would be x plus 3 and x minus 3. Same thing here. What is the square root of 25? Well, that would give me my square is 5. So square root of 16, same thing, gives me 4. So this is the same as saying 4 squared and 5 squared. 16 is equal to 4 squared. 25 is equal to 5 squared. But yet we have these additional variables to incorporate as well. So we have 4x plus 5y squared, a plus b, right? So originally we had 4x. If this whole thing was squared, then we'd have 16x squared. So that's the same as saying our a is 4x and our b is 5y. But it's not just y squared, it was y to the fourth. So we had to start with y squared because 2 plus 2 is 4. So b was 5y. So a minus b is 4x minus 5y squared. Another special case of factoring is when we're dealing with perfect square trinomials. So we have a squared plus 2ab plus b squared is the same as a plus b squared. A minus b squared is the same as a squared minus 2ab plus b squared. So in the last chapter we were writing this out as what is a minus b squared equal, and we wrote it as a trinomial, and now we're going to be given the trinomial and work backwards to write it in its factored form. So here's just an example. So if we're looking back, it's a squared plus 2 times a times b plus b squared. A squared plus 2 times a plus times b plus b squared equals a plus b squared. So how do we figure out that this is a 4? So this was a squared plus 2ab. My cursor is not working. There we go. Plus b squared. Okay, looking back, just all I did was copy this expression right here. A squared plus 2ab plus b squared. It's all positive. B squared is 16. So what is b? B would be the square root of 16, which is 4. 4 times 4 is 16. Okay? Because we were doing a plus b squared. A was x. If I just take the square root of x squared, I would get x. So there's our a and there's our b. Okay, the next one is 9x to the fourth minus 30x squared times z plus 25z squared. And this is represented as a minus b squared. So we just need to figure out, well, what is a And what is b? So if we're looking back at this, it's the same format except our first sign is negative instead of positive. So we have that a squared. So I need to figure out, well, if this is a squared, what is a? What does a equal? Well, take the square root of everything. What's the square root of 9? 3. And what's the square root of x to the 4th power? Well, that would be x squared. Okay. This is b squared. If that's b squared, then what's b? Let's take the square root of it to figure that out. Square root of 25 is 5. And the square root of z squared, well, that cancels that. Square out, remains with just a z. So 5z is our b. And we can plug those into a minus b and put our squared sign on the outside of our parentheses. Okay, here's another one, factoring 2x squared plus 4x minus 16. All right, so we can first factor out a common factor. They all are divisible by 2. 2. So take out that 2. Now we're left with x squared plus 2x minus 8. Now we can factor this out nice and easy, right? What numbers multiply to equal negative 8, but add to equal 2? And I'm able to do it this way because we no longer have a coefficient in front of that x. 4 times 2 is 8. 4 plus negative 2 is positive 2. So positive 4 and negative 2 are those two answers here. Again, let's start with, can I factor out a common factor? They're all divisible by 5 because they all end in a 5 or a 0. There's our special rule, right? So if we take out a 5, we're left with 9, 24, and 16. All right. Now I can say this is not factored all the way. What can we do to factor this out? Is this written in the format of a squared minus 2ab plus b squared? I can determine that by asking myself, am I able to take the square root of 9? Yeah, that's 3. And am I able to take the square root of 16? Is this a square? Yes, that's 4. So there's our numbers, 3 and 4. And how do I know that this is a negative sign? Well, go by your middle value. It's negative. So 3x minus 4 squared. Okay, we'll just go through 2 more examples for this section. 12x squared minus 48. Factor. First, greatest common factor. They're both divisible by 12. Pull out that 12. We're left with x squared minus 4. This one's easy because we know that a squared, x squared minus b squared, a squared minus b squared. 4 is a square because 2 times 2 is 4. And that's the same as a plus b times a minus b. And 2 times 2 are the numbers that would equal 4. So it's x plus 2 and x minus 2. All right, last example. Greatest common factor for 24, 72, and 54. We can factor out a 2, but we can factor out something bigger. We can factor out a 6. So if we factor out a 6, we'd be left with 4, negative 12, and 9. So now I want to look at these. Focus in on the first number and the last number. Can you take the square root of both of these? Yes, you can. Square root of 4 is equal to 2. And the square root of 9 is equal to 3. So this is in that format of a squared minus 2ab plus b squared. So I have a squared minus a minus b squared. 2x minus 3 squared is our way to simplify that even further.